All right, my friends, welcome. Hold on.
I love when that happens. I just do this. I'm turning it on and on again. Okay. Davidson, I can't. Because I thought I was like, oh, I don't have that bad a vision, and then I realized
Apparently you do. Okay. Today's plan. Have a seat, please. All right, here's my plan today. We're going to talk about titrations for a little bit of time.
We talked about this yesterday.
Right. And then we're going to start our review.
Let's go.
Sound easy enough?
Are we going to have a 2-day review or a 2-day test?
You know it.
Yeah.
Is that okay? Okay. So titrations. All right, so we have this little setup. All right, I did it yesterday. We have our burette right here. Has a little valve right here. And then we would have an unknown concentration, but a known volume of something. It's usually an acid or a base. So let's say it's an acid. All right, that would mean if we used universal indicator that the acid would be red. Sound familiar? This is just the same thing we had set up over here. All right, then I want to know its concentration. Now, let's say that I do know that I have 100 milliliters of this unknown concentrated solution. Okay, that's what I do know. What I'm going to do, I'm going to take some NaOH, and I know it is 2.5 molar in its concentration. So far, sort of okay? Yeah. All right, and what I'm going to do, I'm going to turn the valve, and I'm going to add NaOH until this turns. That was satisfying?
Yeah, that was like really
good. Until this turns green. Once it turns green, I'm going to stop it. Okay, let's say, I should have done this at the start. At first, let's say it was at 5 milliliters. And they're kind of weird how they're upside down, but it's fine. It's just the difference. All right, and then let's say after I added, it went to 38 milliliters. I do 38 minus 5 to find the amount of base. So 38 minus 5 equals 33 milliliters of base.
Is that base in the solution now?
Yeah, well, it's not a base anymore, but it's been neutralized. But yeah, I added it to the solution. So I have 33 milliliters of base to neutralize the acid. Okay, was someone asking me a question? Yeah. It was red. But it really depends on the indicator. Most of the time, they'll use bromothionyl blue and the acid's yellow. Go.
Sorry, yesterday I was talking to my friends in bio where their neutral was clear.
Okay. Okay, so that's phenolphthalein. I probably have over 100 indicators in my back room that just are different colors depending on what their chemical formula is and the pH. Yes, sir. Um, it's definitely probably not that high, but we can do the math and figure it out. You could, but I don't, just in my head, I don't think so. All right. So this is what we would do. The equation for titration says that the volume of the acid times the molarity of the acid, I don't know why I'm putting them in brackets, those are just parentheses, equals the volume of the base, and these were parentheses too, times the molarity of the base. Okay, and the reason this works, we talked about it for a second yesterday, it's because volume times molarity gives you moles. Oh my, what is wrong? And this would give you moles. And if I'm neutral, tell your partner what I know about the moles. They are equal. So that's where this equal sign comes from. I can make up whatever acid I want. Typically, we'll just use HCl because that's easy. It's a 1-to-1 ratio. Okay, so here we go. So now I'm ready to do some math. I'll do this in blue. The volume of the acid was right here. And I can use milliliters the whole time. I don't need to convert. 100 milliliters times the molarity is what I didn't know. So I'm going to say 100x, are you okay with that? Is equal to the volume of the base. That's why I did the process. It's 33 milliliters. All right. And then the molarity I said I knew was 2.5. All right, math-wise, I take these two numbers. I keep doing that, that's confusing. I multiply these two, and I divide by 100.
Oh, you divide by 100 first. Okay, I see. Oh, wait, no, that's the whole thing. So I was right. It's 8.25.
It's probably 0.825.
You didn't divide it by 100. Well, I can't see. Maybe I didn't.
Multiply 33 by 2.5 and divide by 100.
I got 0.8. Oh, yeah, 0.825. Yeah, you probably divide by 10. There's too many circles and blurs.
You can complain, but remember that was your decision, not ours, so we don't have to suffer for it.
So that's the total answer.
That's the answer. The concentration of the unknown acid was 8.25 molar.
Molarity concentration.
Yeah, molarity is a unit of concentration. It's capital M, and capital M really means moles per liter. Okay, now I can type faster than I can write, and you can read my typing probably better. So let me just type a problem real fast. I've started a fight. Let's see how this goes. Okay, I win again. Okay. So we'll do this practice problem, and then we'll get out of here. We'll start reviewing. Ooh, my hoodie things are hitting that. Oh, okay. Let's stick with HCl. Oh, whoops, I need the concentration. This is going well. How about 1.3 molar HCl? This is a weird angle. I might as well have just written it, right? Whatever, you know what I'm supposed to say. Oh, geez, that's what happens when I don't look.
So I don't think you thought 45 millimeters or 200 milliliter of 1 point. Is it 4.45 or 2?
Oh, yeah, what did I put that for? How many milliliters of 1.3 molar HCl are needed to completely neutralize 45 milliliters of 1.9 molar? That's what it's supposed to say. Oh my gosh. So I guess I should just write, because then I'm looking and going slow enough to think at the same time. Okay, now this is how these typically are written. They're just usually multiple choice questions or really short. You're not going to give me the option? All right, fine. So see if you can figure that out. Yeah.
Yeah, it's a super fast problem.
I don't think I'm thinking.
What am I doing wrong here? So many things. How about that?
That's good.
Okay, if you don't know where to start, then I'm obviously an ineffective teacher. Yesterday, you should have written something in your notes. It was a saying about titrations. It said, ultimately, the math comes down to just doing one thing, and I wrote out a saying. Anyone remember what it was? Thank you, Grace. Multiply the pair and divide by the loner. So look at the screen for a second, and you'll see two numbers that are paired. What?
You said multiply the pair and divide by the one. That's what I was doing.
Well, okay, don't yell at me.
I wasn't yelling.
Okay. $45 times 1.9 divided by 1.3. That is all you have to do.
Wait, so you do how many milliliters are needed? Wait, so yeah, why is the 1.9 go on the top, or like what?
These two numbers are paired. They're discussing the same thing, which is the NaOH.
So the ones that are paired are always going to go on the top.
Yep, and they're always connected by the word of.
Oh, okay.
And they're always by each other. Like,
And they're always going to be on the top over that.
yep. So what do we get here?
It's like this kind of question will be right on the test. Like this is titration.
Yeah.
Oh.
65.7. Who had that? 65.7. All right. Now, if we were, I'm not going to draw it all the way out, but if we were drawing this out, we would have added 45 milliliters of this, all right? And we would have been able to calculate that if I knew this, but I didn't know the milliliters, like we could have done the titration and gotten that same thing through doing it and then doing the math. But honestly, 90% of the time you see a titration question, it's written for you. You have 3 of the 4 variables and you solve for the 4. Okay, that is titrations. Now, they are way more complicated than that, especially when you get diprotic acid and a monoprotic acid. This is going to be annoying, so I'm going to put these down here. But we'll get those when we do our other chapters later in the year. So I need you. Here is a review worksheet. We will discuss. Oh my goodness, I could use some lotion. Love the winter. Took one cold day and my knuckles already started to crack. I don't know if you guys have that problem too. I think there's 2 there. You're welcome. Thank you. All right. So let's talk through this. If it's too small to read, I don't feel too bad because you are the one that didn't put your contacts in.
I lost one.
Oh, we'll just close one eye the whole time.
Do you have monthly or daily?
Monthly.
That was a joke, by the way.
You need to start getting daily.
Okay. What I'm calling the start or the front is the one that says review topics. Are you with me? Okay, let me describe how this test will go. First off, it's hard. You're welcome. It's because I love you. That's why. So, first off, the test will have 20 multiple choice questions. 20 multiple choice questions. Those 20 questions come from things that we review here, and definitely they could come from anywhere from chapter 1 to chapter 4 of our online textbook. Now, most of it is from chapter 3 and 4. I don't think really there's any from chapter 1 and 2, but whatever. All right, and then there are 8, I think. It's 8 or 9 that are free response. Now, only a couple of those are a genuine like math free response. There's 2 of them. The rest could be just like filling in blanks of a short paragraph, but whatever. So that's kind of the format, and it'll take 2 days. Well, I mean, if you try, it could take you 30 seconds. Last year, I got a test turned in, and it was a duck with a really big butt, and it just said, "I drew you a thick duck," and that was it. So he was done fast. Yeah, he failed because that was not an option. Like question 10, please draw a thick duck with 2 C's. I think he had 3 C's. Anyway, maybe yeah. That person did not pass and dropped after first try. Shocker. They were a fun person, but not to teach. Okay. Anyway, be ready. This test is hard. The next one after it is not hard at all. So if you bomb it, like there's hope. But chapter 4 and 3, it's usually what I call the unit 2 test, it's a really good predictor on whether you can pass the AP test. It's a really good predictor. If you bomb this, you should not even consider paying a penny. I know it sounds harsh. What's that? It's $40 to reserve it, $55 later by November 5th. I don't think so. I don't know. Pay with a check because then they don't deposit it for a while. I don't know. That's up to Mumford. But here we go. You need to be able to use the term solute, solvent, and electrolyte to describe a solution. Remember when I turned the light bulb on and off with liquids? That was showing you electrolytes. Electrolytes are solutions that allow electricity to flow through them. A solution is made out of 2 parts. The solvent, which is the liquid typically, and the solute, which is the solid. So if you were describing a salt water solution, you would say that the salt is the solute, water is the solvent, and its ability to conduct electricity makes it electrolyte. There are a couple of multiple choice questions about an electrolyte. Please remember the definition of weak and strong, and it has to do the same with acids and bases, so that's the next row down. Weak or strong electrolytes, acids, and bases. Weak, it doesn't mean they're not dangerous, it just means they don't dissociate completely. So vinegar is a weak acid because it mostly stays together as an acid, not an H plus and an acetate. Yes, sir.
So the closer it would be to like neutral, the less, the weaker it is, right?
Correct. That's a good way to put it. So vinegar is like a 3 or a 4, and hydrochloric acid is a 1. So, yep. If it doesn't dissociate, it typically has a more neutral pH. Acids and bases. Yep. Okay, now you need to know the identity of the strong acids and bases. And if you don't remember that, look, you wrote them down. I showed them twice. I remember you writing them the second time too, saying, well, I showed this 2 days ago. You don't need to write them down again. If you can't find them, just search Google. It's not hard. Say, hey, Google, what are the strong acids or bases? Unless you use an iPhone, then you got to say series. Yeah, you just got to know them. There's 6 or 7 of each one, and this is just straight up memorizing. Yeah, that one I think you have to circle from a list. What are the strong and what are the weak or something like that. If it's high, I think it's calcium and lower are strong bases, and magnesium and beryllium are the weak ones. Because it's family 1 and then BA, SR, and CA. All right. Sort of all right with that? Okay, next, a basic understanding of redox reactions. You need to know what element is oxidized, which is reduced, and how to find the oxidation state. Okay, so like finding oxidation state, you have to do that, I think, more than once. So just to review, if you had KNO3, the oxidation state for oxygen is always a -2. For a monatomic cation, it's just equal to its charge. So then we'd have to figure out N. N gets bossed around by oxygen, remember. Also remember that these always add to 0. So we have 3 times -2 is -6, a +1 here. So +1 something -6 equals 0. So N's oxidation number here is a +5. Okay. We've heard of, this is nitrate. We've heard of nitrite. I can have potassium nitrite. What changes here? All right, so it's the oxidation number or oxidation state of nitrogen, which is changing here. So now I have a -4 something and a +1. So this would be a +3. So on the exam, this one's multiple choice. If I remember, one of them is multiple. There's more than one place you need this. But it says, in which of the following things is sulfur's oxidation state the largest, or something like that? And then it would have like A, sulfur, B, SO3 minus, C, SO4, yada, yada, yada. All right, this is -2. Okay, and you could, for each one of these, say, well, this is a 0. Then you could do the math. All right, but the more oxygens you get, the greater negative value that is. Now, if that doesn't make sense, just calculate them and then circle the one. And it or not negative, more positive. And that's,
So what was that balancing for? So like when there's more oxygen, it's going to be a higher state.
right, because
So then what was like the K, like the balancing within like what was that for?
right here,
Yeah, just like what?
it was just every compound has to be neutral. So we use the fact that potassium nitrite, that it's a neutral compound, we can use that to figure these values out.
Oh, so just you find all the charges of each part.
And in this problem, I'm pretty sure there's things like K2SO3, K2SO4, like it's a compound, not just the ion, if I
And
remember
then
right.
you just have to say, okay, that K would be +2.
Yep.
It would be whatever. If it's just one, the higher the oxygen, the higher the.
Pretty much. The more positive the oxygen state of its partner. All right, if I had calcium solid plus AgNO3 aqueous, a reaction will happen. I will end up with CaNO3 2 plus Ag solid. On the exam, you'd be given words. It would say calcium, I'm just going to scribble, is added to silver nitrate. Okay, yada, yada, yada. Balance it. Okay, so it would give you these as words. It would tell you to write and balance it. So we'd have a 2 here, a 2, a 1, and a 1. And then if it was this type of problem, it would say which element is reduced and oxidized. Okay, they're two separate ones. That's written kind of weird. But so you would say, all right, I need to assign oxidation numbers. This is a 0. This is a 0. Now, save yourself some time. NO3 is together on both sides. So is it going to be oxidized or reduced? Is anything going to change? No. So don't even worry about that. Silver now becomes a +1. Calcium becomes a +2 here. So calcium went from a 0 to a +2. Silver went from a +1 to a 0. Well, you think that through and have a discussion with your partner, which one would be oxidized and which one would be reduced?
But I think that's being reduced, it's losing the oxygen. It's being oxidized, it's being going to oxidized. Silver because silver is gaining an electron.
All right. So Leo the lion says grr. So lose electrons, you're oxidized. Lose electron also means you become more positive. Gain electron means you become more negative. Okay, so calcium went from a 0 to a +2. Did it become more positive or more negative? It became more positive. So it lost electrons and calcium was oxidized, which means which one is reduced? AG. Leo the lion says grr, or oil rig. All right, oxidation, loss of electrons, reduction, gain of electrons. Okay.
Did you remember it? Because if anything gets oxidized, it's joining with the oxygen. Anything that gets reduced is losing oxygen.
That's just, I mean, and that's valid, but it doesn't always follow that. Because really, oxygen is not even in here. I know it looks like it is, but it's nitrate that's doing it, not oxygen.
Well,
Speak.
yeah, but like the oxidizer.
If it makes sense in your head, yes.
So why did we assign zeros to it?
Because any element in its natural form is neutral, meaning its oxidation state is 0. So if you were to find a piece of calcium, it's not going to just naturally have a positive charge. It's just chilling at 0. But if you found a solution of calcium nitrate, the oxygen has nothing to do with it. I know you want it to, both of you, but it doesn't.
Oh, it's just because the NO3 charge is -1.
Right? And there are 2 of them. Okay, so when we get solutions of calcium nitrate, really, I do have a Ca +2 in your Powerades that have the power of 4. Ca +2 is one of those 4 ions. So, but
The whole idea of like when it stands alone, it's not like a +2 just because it's that.
it's just, it is what it is. Yes. I better move closer. All right, sorry. Speak again.
I'm just reminding me why we use like the charge of nitrate to balance it instead of like a different number. And the other ones are different, so that one was charged. I guess how did you know what nitrate was?
How do I know it's charge?
Well, no, like so how would you use its charge and not charge on other ones?
I'm so confused.
So, you do.
Help me, Bennett.
Why is the oxidation number the same as its charge?
Okay,
Right.
maybe. I didn't, NO3 doesn't have an oxidation state. I just didn't do it. Because I didn't, I'll show you why. I don't need to. Whoops.
You want to do one more like this?
If you guys want me to.
Honestly, it's kind of just like balancing.
You guys are paying. All right, yeah, it is balancing.
Just balancing the charge.
NO3, I know O is a -2 always, right?
NO3 always goes to -2.
No, O always has a -2. This is the oxidation state. This is where we get confused. Because oxidation state versus charge, they're two different things, even though sometimes they're the same. All right, so the O is a -2, and the N here is a +5. Okay, now I know that seems weird. -2. This is a -6, but NO3, does it equal 0 itself? No, it equals a -1. So this becomes a +5. All right, and this doesn't actually exist. Like it helped us to find this, but these are my oxidation states. This is my charge of NO3.
That's why a K would like offset it.
That's why the K worked. Yep. Now, the reason I didn't find +5 and -2 is I knew since this is all one thing together on both, well, nothing changed. And I know that if nothing changes, then nothing changes. Does that help at all? Then the subscript came from, I know this is in family 2, so it's also a +2. I knew this was a -1 charge, so I needed 2 of those. Did that clarify anything, Nisha? It's hard to read. Obviously, that's a no.
Nisha, I can help explain it.
So the AG
Well,
was
hold on.
oxidized and the CA was reduced.
In this one?
Yeah.
No.
Wait, actually. Oh, AG was reduced.
Judah.
So on this test and future tests as well as the AP test, do they usually give us the back end of the problem too?
No. They expect you to be able to find the back end of the problem. And I do too. I expect you to be able to find the back end of this problem.
So if this was on the test, it would just say CA plus, like the test would not say.
The test would say calcium metal is added to a solution, it might say aqueous, but it doesn't have to, of silver nitrate. Then it would say balance, and then it'd say oxidized, that's supposed to be a question mark, reduced, stuff like that. Tom Davidson, your chemistry teacher right now, my expectation is you can do this. You would say, all right, calcium plus silver nitrate, Ag. I should know by now. I've been telling you for over a month to memorize the polyatomic ions, especially nitrate. We use it a ton, and you'll use it on the test. It's 100%. It is on the test, I promise you. You should know silver by now is a +1. You should have memorized NO3 is a -1. Then you'd put your arrow. And then we talked about this yesterday. Are Ca and Ag going to hang out? No, they're both positive ions. So only if you don't bend them. All right, CaNO3, and then you'd have Ag. But then you'd say, all right, well, calcium's in family 2. I already know nitrate's a -1. Oh, I got to drop and swap. And from there, you'd be like, okay, I need to balance. 2 NO3s on the right means I need 2 NO3s on the left. Oh, that means I just made 2 AGs, so I better put a 2 AG right there, and a 1 and a 1.
So I don't mean just on oxidation reduction. It's like
On every single thing now, you should be at a place where you can complete every reaction. Now, decomposition reactions, I haven't gone over yet, so I won't give you one of those, but eventually those as well. Go ahead.
So reduce is when it's going from like a state.
It becomes more negative.
So it's just what you think. It's just the same thing. Like reduced.
It's up to you, but it gained to be reduced.
Okay, and then oxidized is just like
It lost to become more positive.
lost pause.
It lost to become more positive.
Oh, it lost electrons too. Okay.
So
Sorry, I'm just
on
You're
the
fine.
class, will you do ones where calcium isn't by itself? Where calcium is with
Yeah, I reserve the right to say that this is calcium bromide.
And then we have to know which one's an like which one is like the one that oxidates.
This would not be an oxidation reaction. What would this be? Help me, help me, help me.
Double replacement.
It's a double replacement with a what? A precipitate.
Yeah.
Oh, good. Because I was about to roll this window open and jump out. All right. And I shouldn't be frustrated, but you need to be ready on Thursday. The other one, if I undo, this is an oxidation reduction reaction. I know it because there's lone elements. That's the key. If there's lone elements, it's an oxidation reduction reaction. This one, if I redo it, this is a precipitate reaction where I've learned that nitrate never forms a precipitate. So these are my spectator ions, which means this must be my what? Precipitate. So this, hold on. So you should know that's a precipitate reaction. The other one, since it had lone elements, is a single replacement reaction, which is an oxidation reaction. Speak.
Yeah, that's what I was asking. I was like, aren't lone elements oxidation?
Yes.
It's not going to be two, or that would be the precipitate.
Right.
Okay.
Okay.
That makes more sense now. No.
Okay. Now, Marie, did you want another oxidation reduction one still?
How much more stuff do we have to go over?
That worksheet.
Let's go over the worksheet.
Wait, and then so pretty much we just have to like with the oxidation reactions and those we just have to state like what the spectator ion might be.
Yeah, you have to be ready for me to, it varies. I will give you a stem and require that you balance and require you to answer one question, just one. So really the other one, it would have just been which one was reduced. And you'd balance it and get out of there. Technically, if you're bright, no, that sounds rude, you're all bright. If this clicks well for you, you wouldn't even have to do this crap. You could quickly be like, oh, AG, that's the one that is reduced. Like you don't have to do that. You have to balance it, but you don't have to do the lines at the top. It's really confusing with all the scribbles right now. Okay, the precipitate question, it would say this, like calcium bromide, is added to silver nitrate, and yada, yada, yada. And then it would say, what is the precipitate, or something like that. And then you'd say, all right.
Just ask what's the precipitate, or will it ask you to do stoichiometry?
In this section, there's no stoichiometry.
So it'll be like balance and then just like state precipitate.
Yep, that's what these are right here. We're to here on the review sheet.
Oh, okay.
What?
Is silver a negative too?
Silver's a metal, so it's positive. It's a 1 also.
Wait, and then okay, and then just kind of memorize like with the strong and weak ones that are flags.
Yeah, okay, so it gets harder. Like I hate this class so bad. But I love you, just remember that.
Oh crap.
Even if you fail. Remember your red flags when something reacts with an acid. Not nitrate. Sulfite, carbonate, hydrogen carbonate, sulfide.
Wait, what is this for? What's a red flag again?
They're when they don't go the way you think they will go. So let's do a red flag example. Sound good? I'll put it in a nice wavy red flag here. Okay, so here's my red flag. If you had an acid plus like sodium sulfite, whoops, that would be a 3. And then it would ask you to finish it, okay? And it will have more, we'll talk about it. So you would need to know the following, and this probably would have said solid. And this is aqueous. How do I know HCl is aqueous?
Acid.
Not because it's an acid.
Because isn't Na a family one, so it shouldn't be a solid? Oh, but it goes against the way you think it is.
No. Slow down, Coop. HCl is a strong acid, so it's always aqueous.
Oh,
Okay, well, wait, but isn't Na a family one, so it can't ever be precipitate?
Yeah, but stop talking. Precipitates are only on the right side.
Oh,
I'm just saying I'm adding an acid to a powder.
Okay.
Okay, so here we go.
Wait, but still, I didn't think it could be a solid. It really is,
Yeah,
yeah?
it can. I can get some out of my back room if you want me to show you.
Trigger one.
It's like
I just
salt.
thought we never put a family.
Well, look, stop.
Okay.
Can you have table salt?
Yeah.
It's just a solid crystal, right? Before I put it in water, it's just a white crystal, right? Even though family one should always make or never make a precipitate, right?
But I guess it did. Huh?
It will later. Precipitates are on the right side.
Oh, because I guess NaCl, that's all out of
This is,
solid, right?
yeah,
And it's a solid.
it's a solid until you dissolve it. So I'm going to take an acid, liquid, drop a solid in it, and we're going to see what happens. Okay, this has a red flag. We just said sulfite is a red flag. This is sulfite. So, and who's feeling like they made a bad choice in this class?
Okay, wait, but how do you, so yeah, how do you finish it?
I will.
What does that mean?
I will.
Okay.
So you need to remember that when these happen, when an acid reacts with a sulfite, the product includes a gas. So let's finish this real fast, and I'm going to finish it wrong first. I would just break my couples up and reform, and that's what most of you will do. You'll end up with Na and Cl, but you need to put aqueous here. The difference now is once I've added the liquid to the solid, it's now in a solution. Okay, the other product would be H and SO3, and it'd be H2. Now, here's the red flag. This is not what happens. We should memorize that H2SO3 is really H2O and SO2 gas. That's the real reaction. Now, hold on. The question, this is on the AP test all the time, and it'll say finish it. And then the question that they follow up with says, where should this reaction be done? And you read that and you're like, what? Under a fume hood is the answer.
Under.
And then why it's trying to elicit that is because you know it needs to be in a fume hood because you know it produces a gas.
There's been a lot of funny answers about in my kitchen.
Yeah, I don't know.
So you just gotta memorize it. It's always gonna be H2.
The only one that doesn't make water though is sulfite.
Is sulfide. You want to look at that one?
Okay, wait, so really quick though, is that only with an acid?
That's only when an acid
Because sulfide or sulfate
reacts with one of those.
You can trade partners and be fine if it's not with an acid.
Correct.
Okay.
Okay, so here you go. How about this one gets kids a lot?
So in that other one where you showed us the wrong way, NaCl was supposed to be there, right?
I want to say hydrogen.
Yeah, that was still there. It was just a spectator. Well, Cl would have been. Okay.
Sorry, I'm just.
I don't care. Do you want better light?
I was just gonna take a little. I'll just turn the flash.
Okay. Okay. Now look at this. We should be able to do this. Go ahead. No. I like the resilience. One guess, you're wrong. I quit.
I mean, they're gonna
and have.
I didn't say I quit. I just said I
So
was lost.
MgSO4 is gonna.
So here we go. Let me see if I got this working right. Okay. So I just split up my partners and I move them around. So I'm going to say Mg is now with who? SO4. Now, I would need to check my solubility rules. Sulfate is usually soluble, with some exceptions, but magnesium is not one of those. So this is aqueous. Plus, I'm left with H2S. And then your red flag is to think, well, is this a precipitate, aqueous, or is it a gas? Which it is a gas. And this one's bad. This is the one actually that can kill you. So this one you definitely need to do in a fume hood. It's a nerve agent.
Let's say let's say do the acid red flag and balance, or we not have it balanced.
You would have to balance this too. I think I have it all balanced. I made this a 2 and a 2.
Yeah.
So is this one of the few ones you can switch partners and do fine?
It's fine. You just have to remember this is a G. That's the only thing that screws things up. Okay, then it might say, what's your spectator ion? There's only one spectator ion right here.
SO4.
Good. SO4 is your spectator ion. To find spectator ions, don't rewrite it. Just do this. Put both things that have an AQ in a box.
Oh yeah, 'cause gases.
And then right, and if anything repeats, that's your spectator ion. So what does it have in common?
SO4.
SO4. So this would be your net ionic. Okay. I know I'm having fun.
What do you mean by
What do I mean by what?
repeats? Like, because you could say H2 repeats in those boxes.
Not in the boxes. Is H2 inside this blue box?
No, okay.
Put a box around both things that are AQ and cross out anything that repeats in the boxes. This is going good. Oh man, it's good to finally make you guys realize how everyone else has felt their whole education. Nothing's been hard for you your whole lives. And you're like, why is that dumb kid not able to do this stuff? It's so easy. And now you're the dumb kid. Not really.
Davidson is on the very top.
No, this took me forever to get good at. This right here, this is crazy hard.
Okay, so but like red flags, like yes, it's pretty like it's quick to like memorize and know, but like you're not gonna like stack the test with like red flags and like.
No, there's one.
Right? Okay,
There's one of these,
I'm just nervous. I'm gonna like go in and it's gonna be.
one of these, one of these, and one of these.
20 points worth of red flags.
I just thought it was multiple choice. I can do multiple.
Okay, so right, balance precipitate, acid base.
A what?
And acid base.
Okay, acid base is, they're the easiest in my
So
opinion.
redox is
Acid base is. Which one was that one? You just have to identify it.
Well, it would say something like sulfuric acid
Uh-huh.
is added to hydrochloric acid. Give me the net ionic equation and tell me your estimated pH. Whoa, that doesn't seem familiar. Like, how can he do this to
When did
me?
pH come into it?
It just came in because I wrote it and I feel good about it.
Feels good.
I don't know if it's on the test or not, but look, everyone should be able to answer this. Let's write it out. What's sulfuric acid?
And that's gonna be HS.
Nope.
2SO4.
What's hydrochloric acid?
That's HCl.
Let me check something. You should check something. Is this a strong, oh, did I say, why did I put two acids? I have no idea why I just did that. This, sorry, that's a base. That's a base.
That's not a base though.
Sorry.
I was like,
That was just stupid. I didn't keep track of what I was writing. What's your favorite base? Sodium hydroxide.
Yes, I like that one.
Sorry about that. I was an idiot. Okay, coming back here, is this a strong acid right here? H2SO4.
Yeah.
Yes, because you memorized it.
Oh, wait.
There's
that's-
no
wait,
other
wait, wait,
answer.
wait.
Davidson, what did you
Because
just say right
like-
there?
What?
What did you just say 2 seconds ago?
I said, is it a strong acid? And the answer is yes, because you memorized it. Because he's about to give me a reasoning, but it's
Oh,
wrong.
but
Is
so-
it really? So, my dad was teaching me
You.
if you have more, or if you have more than one extra oxygen to hydrogen, then it's a strong acid, likely.
Likely, but not 100%
Not 100%
true.
of the time, but enough to get me an A, right?
Probably it would work, but no one else listen to that. Cooper, what?
So sulfate is strong.
Yep.
And then you.
All right, now, I gotta hurry. NaOH. Is this a strong base? Yes,
Yeah.
because I memorized it.
Oh, those were all the strong bases. Do I only have to know strong bases?
No, you have to know strong acid and strong bases. Okay, now,
Yeah.
what happens when a strong acid and base are added together? They make water and a salt, which is Na2SO4. Is this a precipitate? No.
That's obvious.
So my net ionic is H plus OH minus goes to HOH. And what would be my pH? It's 7. They made water, which hopefully all of you in AP chemistry know has a pH of 7. If you don't, you do now.
So that's probably the answer to a pH question.
That could be. I have a question like this and it is not. It's worded a little different, but
How do you know what the pH is? Other than if it's water and 7.
What did we just say, base?
I won't ask you one now that requires you to do anything besides think, oh, that's neutral, which is 7. The pH
pH always equals 7 right now.
for now, because there's a whole chapter and a half about pH. Chapter 16 and
So it's
17.
not in this one, the net ionic would be H plus OH, because wouldn't OH actually be a spec? Never mind, actually.
Nope, because we put everything that's aqueous. All right, and then we can erase here and here, but we can't erase those and those.
We didn't erase SO4 though.
Yeah, sorry.
Okay, yeah.
Okay, we got to here. The rest is mostly math.